Let's do section 10.1, page 486, number 33, which reads, use the series centered at A and the function it represents to find a power series for the integral from a to x of f of t dt. And for number 33, we're supposed to use the power series from exercise 23, which is right here and tells us that we have the summation from n equals 0 to infinity of -1 to the n times x minus 3 to the n. Now, it might be useful to figure out what function this represents and what the interval of convergence is. So let's start by writing out the first few terms here, and the n equals 0 term is going to be 1. The n equals 1 term is going to be -1/2 times x minus 3. The n equals 2 term is going to be -1/2 squared times x minus 3 squared. And of course, this is going to go off to infinity following this pattern. And by this point, we should be able to recognize that this is a geometric series. And remember that we represent a geometric series as a over 1 minus r, and that converges for the absolute value of r less than 1. And for the series that we have here, we've got a is equal to 1 and r is equal to -1/2 times x minus 3. So the function that this series represents is going to be 1 over 1 minus -1/2 times x minus 3. And since we're really interested in what the function is, we can do some simplification. And the first thing that I'm going to do is get rid of that double negative sign in the denominator. So that's going to be 1 over 1 plus 1/2 times x minus 3. And then I'm going to multiply both the numerator and the denominator by 2. And so that's going to give me 2 over 2 plus x minus 3. And then I'm just going to clean up the algebra in the denominator again, and I'm going to end up with 2 over x minus 1. And we said we also wanted to know what the interval of convergence is, and this series will converge for the absolute value of r less than 1. So we're going to substitute in with that, and I'm going to take the absolute value of my r, which is -1/2 times x minus 3, and that has to be less than 1, which is the same thing as saying -1 is less than -1/2 times x minus 3 is less than 1. And I'm going to begin the simplification by multiplying through by -2. And remember that when you multiply through by a negative number in an inequality, you have to flip the signs of the inequality. So this is going to give me 2 is less than x minus 3. And I've already forgotten to flip them because, let's see, this should really give me 2 is greater than x minus 3 is greater than -2. And then I'm going to add 3 to all sides of this. And I'm going to end up with 5 is greater than x is greater than 1. So this is going to be my interval of convergence, and this is my function. Now, if we remember what the problem is asking us, is it wants us to find a power series for this integral up here. So in our case, this a is what this constant is. So we're going to go from 3 to x of 2 over t minus 1 dt. And we want to do two things with this. We want to find a power series, and we also want to find the integral, or the function, by using the antiderivative. So let's start by looking at the power series, and for that we're going to use Theorem 2. So Theorem 2 tells us that if sum f of x is equal to a power series that goes from n equals 0 to infinity, and it's made up of Cn times x minus a to the n, and it's going to converge for some absolute value of x minus a less than r, then basically we can do term by term anti-differentiation or term by term integration, and it's going to tell us that we can let the integral from a to x of f of t dt be equal to this power series represented by the summation from n equals 0 to infinity of Cn times x minus a to the n plus 1 all over n plus 1. And it's going to be on that same interval. And so we can do that. And in our situation here, we have Cn is equal to negative 1/2 to the n, and our x minus a is equal to x minus 3. So this is going to tell us that our function, which is 3 to the x of 2 over t minus 1 dt, is going to be equal to the summation from n equals 0 to infinity of Cn, which in this case is going to be negative 1/2 to the n, times x minus a, which is here x minus 3, to the n plus 1 divided by n plus 1. And we can write out the first few terms if we want to. And that's going to give us the n equals 0 term is going to be x minus 3. The n equals 1 term is going to give us a negative 1/2 times x minus 3 squared over 2. And the next term is going to give us 1/4 times x minus 3 cubed over 3. Then we can go on to infinity with that. So this gives us the power series representation. And then we also want to take the integral of this function. And so we're going to do that right here. And I'm going to start by bringing the 2 out. And that's going to be times the integral from 3 to x of dt over t minus 1. And as we'll be learning soon, if we haven't learned yet, when we have dt over t plus or minus something and we take the antiderivative, that's going to be the natural log of t minus 1. And we're going to evaluate that from 3 to x. So that's going to be 2 times the natural log of the absolute value of x minus 1 minus the natural log of 2. And I can combine this a little bit here. So this is going to give me 2 times the natural log of the absolute value of x minus 1 over 2. And this function is going to be equal to this power series. And it is going to converge on the same interval, which is 5 is greater than x is greater than 1.